Thank you very much for watching this YouTube channel. Thank you for watching this video. I encourage you to watch to the end. Do not forget to subscribe to this channel if you have not done so. And also do not forget to like this video and share it. Okay, so please do not also forget to put your comments and questions in the description below. Put your comments and questions below, and you can be sure that we are going to respond to them. Okay, so today we want to treat a very important topic in the design and construction of civil engineering structures. And the topic we are treating today is how to design a pile foundation. Okay, what inspired this video is because I've gone through a lot of YouTube content and I discovered that there is something missing in most of the videos that I've come across, and I have taken my time to do this video. Okay, so please do not forget to put your comment in the description below. We value your comment. We appreciate your comment. If you've got any questions, please do not forget to put it in the comment section, and you can be sure that it's going to be attended to. Okay, so let us go straight to pile design. So briefly, let me define what a pile is and the things that you are expected to know when designing a pile foundation. Okay, so basically a pile foundation is that column-like structural element that goes straight into the earth. It transfers the load of the building into the earth. Okay, so when you see a pile, in most cases it comes with a pile cap. Okay, so and that pile cap is a structural element that transfers the load of the building to the pile itself. That's the pile cap. It transfers the load of the building to the pile itself. Okay. Basically, pile caps are designed for movement. They are designed for movement. They are designed for shear also. And while designing a pile cap, you have to check for your punching shear. Okay. In addition to this, when you design your pile cap, you have to provide lateral bars to resist busting action. After designing your pile cap, you have to provide for, some people call it bust bars. You have to provide for it so that the busting action is going to be resisted. Okay. And let me say that the pile cap sizes varies depending on the diameter of the pile to be capped. I'm going to repeat it again. The pile size vary depending on the diameter of the pile to be capped. So if you are capping a pie diameter of say 300 mm, it's probably going to, the pie size is going to be, the pie cap size is going to be different from if you are capping a pile of say 800 mm size. Okay, so quickly, I'm going to take us through things, the formulas we need to know. We need to get ourselves acquainted with some formulas, and I'm just going to do that now. Okay, so if you see this now, you can see that here I wrote the pile cap depth equals to 2D plus 100. That is for piles that are less than or equals to 600 mm. 2D plus 100, that is the formula for piles that are less than or equals to 600 mm. So let's say, take for example that you have a pile size of 300 mm. So your pile cap depth is 2 times D, which is 2 times 300 plus 100. So that makes it 600 plus 100. It makes it to be 700. Okay. So for pile cap depth of 600 mm and above, so you have 8D minus 600 divided by 3. Okay. So in all this formula, the representation D, the letter denoted D represents the diameter of your pile. Okay. Also, I simply wrote here that you should kindly note that this formula, kindly note that the formula above should be seen as a guide and not a rule. Okay? So it is a guide. It is not a specific rule. As a matter of fact, all these formulas are coined out from experience, and it's not really a basic rule. Another method you can use to determine the required effective depth is the normal general formula for effective depth, which is M over 0.156 FCUB. Okay, so that is that about that. So the two formulas above, 2D plus 100 and 8D minus 600 over 3, they are not a rule, they are a guide. Okay, so now let's go to your ultimate compression capacity. Your ultimate compression capacity is 1.4 times safe working load. Now, somebody is going to ask me, how do we get this value for safe working load? Okay, so I'm just going to quickly show you a soil report. Your safe working load is always in your soil report. Let me stress that for every pile design you do, always have a soil report. Do not do a pile design without a soil report. It is not a good practice. It is, as a matter of fact, it is one of the worst kind of design to do. It's a worst thing to do. It's the worst thing to do. Or let me simply say it's one of the worst thing to do. Okay? Do not design a pile without a soil report. And let me still say that designing any civil engineering structure without a soil report is not a good practice. So whether it is pile or it is even pad foundation you are designing, or you are designing anything, it is not good to do it without a soil report. Okay, so let me quickly show you the safe working load. Here it is. If you can see my cursor, this is the safe working load. And each of the pie size has different working load. Okay, they have different safe working load. For 300 mm, you can see it here. The geotechnical engineer has recommended a pie length of 8 meters, and the safe working load for this 300 mm cast in place pile at 8 meters is 180 kilonewton. Then for 450 mm board cast in place pile at 8 meters is 295 kilonewton. That's the safe working load. And for 600 mm, we have it as 430. So I do not want to take our time too much. Let us quickly go to the pile design itself. Before you design a pile, you have to design the pile cap. Okay, it is good to design the pile. I prefer to design the pile cap first. You may choose to design your pile without designing your pile cap first, but for me, I prefer to design my pie cap first. You get it? So I'm just going to quickly go to the design of the pie cap. Just like I said earlier, a lot of videos that I've come across on YouTube they are majorly not complete videos. A lot of them dealt with designing the pie cap, leaving the pie foundation itself behind, leaving the pile itself behind. You get? So, and you cannot design a pie cap without the pile itself. You cannot build a pie cap, cannot construct a pie cap without the design of the pile. Yeah, you cannot do a pie cap without the pile design, if you get what I'm trying to say. So, because obviously you are going to build your pie cap on something. So you have to know how to do, you need to know how to design the pile and also the pie cap. And a lot of YouTube content covered just the pile cap. Okay, so in this video, I'm going to be covering the two. Okay, so without wasting time, this is the superstructure. Let's assume I'm done with design of this superstructure in Prota Structures. This is Prota Structures that I'm using, and this is Prota Structure 2021. The design process remains the same. Yes, the design process remains the same for all Prota structures, all Prota structure design, okay? However, the interface for 2021 differs from 2018, and just like I said earlier, the interface differs, but the design process is still the same. Okay, if you want me to do the same video on Prota Structure 2018, kindly put it in the comment section below, and you can be sure that I would attend to it later if people request for it. Okay, so this is Prota Structure 2021, as you can see, and I'm quickly going to design my pie cap. Then I'm going to go to the pile design. Okay, so this is where I have the foundation. I have the pad footing design for this structure already, but for the sake of this video, I'm going to delete it. I'm going to delete the pad footing that I have. Okay, I'm going to delete that now. Oh, good. So in designing your pie cap, the very first thing to do is do your settings, all your settings. So one thing I would like to check is my reinforcement provision. So I'm just going to go to my building analysis. Okay, edit materials. I want to be sure that my foundation reinforcement bars are what they should be. Okay, I have Y12 here. Okay, so I'm going to select Y16 and I'm going to select Y20. Okay, then for my links, I'm going to select 8 mm, I'm going to select 10 mm. Yeah. 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 Yeah, maybe I don't even need the links here because I'm going to be using the bust bars and not a link type of reinforcement arrangement. Okay, so let's just go by that and click OK. Then I'm just going to click close here. Okay, so I'm sure that I've set my reinforcements. I'm going to come here to my settings here. Did you see that? I'm going to come here. Here's my settings. I'm going to come straight to the foundation. I'm going to ensure that I use top bars. I'm going to ensure that I mark this. Okay. Then I'm going to come to the pie cap here. Then I'm going to set my pile information or pile cap data. You get? So this shaft type is circular. That is the pile, as you can see here. This for the pile. This shaft is circular. That's the cross section of the pile. It's going to be circular pile. And the penetration, normally your penetration is always between 75 to 150 mm. So for the sake of this video, I'm going to be using 150 mm. The pie size, as you can see, here, sorry, in the, yeah, here, I have a pie size of 600, 450, 300, and I have different working load for it. For the sake of this video, I'm going to be using 600 mm. Okay, I'm going to be using 600 mm. I'm still going to explain how to choose the size to use. Okay, I'm going to explain how to choose the size to use briefly, but for the sake of this video, I'm going to use 600 mm. So I'm just going to come back to my Prota structure, and I'm going to click, and I'm going to leave this at 600. My ultimate compression capacity, remember I said it's 1.4 times safe working load. So if it's 1.4 times safe working load, my safe working load for 600 mm is 430. So if my safe working load is 430 for 600 mm pile, I'm just going to do 4. Yeah, that's 430 times 1.4. And that gives us 602. So this is going to be 602. Then the default pipe length here is 8 meters, just as we have it in this place. Is 8 meters. Okay. So, and yes, I'm going to leave all of this as it is. I'm going to leave all of this as it is, and I'm going to come back down to pile, and I'm still going to leave. I'm going to, yeah, I'm going to leave it as it is. Yeah. Add space for links here. I'm going to leave it as it is. I'm going to leave all of this as it is, and I'm going to just click OK. So I'm going to come here, and I'm going to select. I'm just going to select everything here, and I'm going to right click, inside pile cap, and it's loading. And I'm going to, yeah, okay. So as you can see, it hasn't designed yet. If you want it to design, you just come to check your settings again. I advise you check your settings. You can see our ultimate completion capacity is 602, and all the data we put there are just as it is. Come to redesign all, then come here, design all. Then just wait for it to design everything. So after it might have designed everything, you can see I have one pile here. So I can click OK. Yep. And you can see my reinforcement, the reinforcement it has provided for me, 7Y20. I'm just going to click OK here. Click OK. And there you go. You have your pile already designed. So I'm quickly going to show you how to select the number of piles. Or okay, let me say, I'm going to show you how to select the size of pile to use according to your soil report, and how to know the number of piles to use. Okay, so I'm just going to switch on the load data for this foundation. So I'm going to come to display here, visual interrogation, column display, and I'm going to select all here because I want to see all the loads that I have. I want to use the maximum loading. Okay, so for this column, now for this, you can now check all your columns now. You would see that if you come back here, you see that your safe working load is 430 for 600 mm, while for 300 mm is 180, for 450 is 295. What you are concerned with is the maximum loading here. As you can see, the maximum loading here is 156, which is this combination 2. And 156, that is the load, that's the imposed load from the building. So 156 kilonewton load can be resisted by a safe working load of 180 kilonewton. You get it? It can be resisted by a safe working load of 180 kilonewton. So as a matter of fact, instead of using 600 mm for this pile, I can use a pie size of 300 mm according to my report. Do you get it? So I'm going to check another one. Let me check one that has greater value. Okay, so this is the maximum loading here is 421. And let us see where that falls here. I have 421. So 421, still it means I have to use 600 mm for that. So 600 mm is the right one for that. And let me also add that you can choose to use two 450 mm because for your safe working load of 450 mm, you have 295. 295, if you use two. So it means you have a safe working load of 590 for a group of pile for two pies grouped together, 450 pipes grouped together. You have safe working load of 590, whereas you are resisting a maximum load of 421. So you are still within that. So you can choose to use two 450 or 600 Now the question is, which one is going to be more economical for you? That is what you now need to think about. Because your design, remember, it must be safe and it has to be economical. Okay, so let's see this one. I want to show you a very big problem with Prota structures that you need to take good cognizance of. Come in. Okay, now the maximum loading for this is 531 kilonewton. Okay, so, and according to my report, my safe working load is 430 kilonewton here. That is for 600 So, and I'm resisting a maximum load of, I'm resisting a load of 531 kilonewton. What that tells me in essence is that I may want to use 531 kilonewton. If I'm resisting 531 kilonewton load, I may want to consider, sorry, let me see. If I'm resisting 531 kilonewton, let's see 295 times 2. If I'm resisting 531 kilonewton, I may want to consider using two 450 pile, because if I'm using two 600 pile, it's not going to be economical for me, definitely. So I may want to consider using two 450 kilonewton, two 450 pile with safe working load of 295 kilonewton. Okay, so those are the things to consider. And if I'm changing this, what you are doing is that you can just come to, if I want to change this now, let me just change this to 450 pile. So this is PC 114, properties, come to properties, and then number of pies raised to 2. Yeah. Pie size 450. Okay. I'm going to leave all this. So my ultimate compression or tension is, my ultimate compression capacity is going to change now, because it's now going to be, since I'm using 450 pile, it's now going to be my safe working load 295 times 1.4. 1.4 times 295, which is equals to 413. So here I'm going to put 413 here. Okay. And what again? Yeah. Okay, let me see. Penetration with T circular. Yeah. Yep. Okay. So I can click design. Okay, so now the major challenge with Prota Structure now is that, as you can see, it has changed this to 5 different piles. Do not worry yourself too much. Another thing you can do is just come here, come to properties. Your intention is to change this. Oh, sorry. Let me check the pile itself. This PC, this 1C14. So just come. Hold on. Let me say that you can do the same thing in Prota details. As a matter of fact, it is easier in Prota details, but I choose to use this. I choose to use Prota structures. Okay, so I can just change this to 2 now. Then I can change this to 450. My pie size to 450. Okay, so and I just going to click design selected. And you can see it's still going to give me, it's probably still going to give me the same thing. It's probably still going to give me the same thing. So, okay. So, however, you can do it in Prota details anyway. I'm going to see if I will be able to do that. You can simply design this alone in Prota details so that you can know your pie size and just put it there. Okay. Okay. Because of time, I'm going to, yeah, this is this about Prota structure, also about designing your pile cap using Prota structure. If you have any comment, if you have any question, please put it in the description below. Okay. I'm going to quickly come to, okay, so let's assume we are done with our pie cap. I'll quickly go to Prota details now. Start by creating a new drawing. Let me quickly do something. This is the pie cap batch, still the same one. So what I did is I opened, let me close so that you understand what I'm doing. So I'm just going to quickly open my, I'm quickly going to open my Prota details 2021. Okay. So all my projects in Prota structures are here. In Prota structure 2021 are here. So this is the one I'm designing. This is the one I'm using as a sample to design. I'm going to click on it, Mr. Kayode. So it's saved as Mr. Kayode, and that's what I've just clicked on. Start by creating a new drawing. So majorly it's expected that it's still going to be reading my file in my Prota structures. So come to design library, PyCap batch design. This is the PyCap we are trying to design still in the Prota structure, where I told you that you can actually do this in your Prota details. So let us quickly solve the issue here now. Okay, so I'm going to click on redesign all, and I'm going to design all. You would remember that you would recall that all my pies are just one pies in the last design, and this is exactly what I have here now. Number of pies for all my pies, they are 1 now. So if you want to increase to 2, it's quite simple. Just come here, increase to 2. When you after increasing to 2, just click on design selected, and you can see that you have your 2005 by 1000 here. Then you can click OK. Then you are going to have it like that. Okay. You can also increase to whatever you want to increase it to. Design selected. You can increase to 3. And as you can see, you can increase it to 3. As you can see, it's increased to 3. You can click OK. So you have it here. Then you can now choose to draw selected. You can choose to select the ones you want to draw, depending on the pie caps you want to draw. Then you can draw everything, draw selected pie caps. See, you can draw your selected pie caps. Let me remind you that you should arrange, you can arrange it very well. Just to save time, I just had to do that. And let me remind you that I didn't change this reinforcement in my Prota details. When I didn't set this reinforcement. So remember to set your own reinforcement you get in your Prota details, if you are using your Prota details, okay? Remember to set the reinforcement to whatever thing you want to use. As you can see, it's bringing 7Y50 here, but it can be changed. Just like the same way I changed it in the Prota structures. You understand when I went to building analysis before? Okay, so not to waste time, let me quickly. So that is that about your pie cap design. Just like I said earlier, also, I'm deleting this now. Just like I said earlier, if you have any questions or contributions, please put this in the description below. Okay, so let me quickly go to the pile. That is that about pie cap. We've covered pie cap. Now let us go to pile design. This is one thing a lot of people don't talk about. Okay, and it's easy to do. But let me say that if you are not a civil engineer, please do not attempt to do the work of a civil engineer. Do not say that because you've learned how to use the software, you want to, design anything, you can use the software. No. Engineering is a technical profession. It's not a piece of paper that you read and understand like that easily. So you have to be trained. Okay, so if you want to design your pile, come to design library, then select pile design. It's going to bring you data. It's going to bring you a data page, and we are going to use this data to do our pile design. But before then, let me quickly show you something in the soil report. This borehole log you see here is a very important thing to have when you want to design your pile foundation. Okay, so when you want to design the pile itself, it's a very important thing to, it's a very important data to have. Okay, so now let's quickly go to that. Remember that I'm not doing the pile design in Prota Structure. I'm doing it in pile details. Okay, sorry, in Prota details, I mean, rather, in Prota details, not in Prota Structures. Okay, so pile geometry, this is what we have. Whatever thing you want to label your pile, let me say I'm labeling it as A1. Obviously, everybody likes to have A1. The type of your section is what you're going to enter here. Is it a circular section you're considering or a rectangular section? Then your pie type, is it going to be board? Then your stirrup, do you want it, your stirrups, do you want it to be spiral or you want it to be circular? Okay. Then your pile length, according to our soil report, our pile length, remember, is 8 meters. And this is it. Our pile length is 8 meters. Yeah, this is it. Yeah, it's 8 meters. So I'm just going to select 8 meters. 8 meters. Your penetration here is from here to here. And that is the part of your pile that is entering your pile cap. Okay, so I'm just going to leave my penetration. I'm going to send my penetration to say 1 meter or 900 or something. Yeah, let me use 1 meter. Okay, then I'm going to, my reference level, let's say it's 2 meters. My concrete side cover, your reference level is this and this to this. Okay, so my concrete side cover, your side cover for your pile, probably 50. I'm just going to put 50. Section diameter, your size, the section of the diameter, your pile diameter is what it is here. So remember that we use 600 as our pile diameter. I'm going to leave this as this. Then I'm going to come to design, mark this working load. Let's say the impose our load, the load we're considering is 400. Your load is going to differ. So you can choose to use your maximum load. And you obviously your load on each columns is your load on each columns differ. So you can choose to do it one after the other for if you feel it's going to be economical that way, or you use your maximum load, or you group them, and you use different the different loadings for different pie groups. You get, so that your design can be economical. Okay, so I'm going to come here, rebar diameters, to select my bar diameters. Okay, I'm not going to use T13, I'm going to use 12. I'm going to use 16, use 20. Obviously, I don't need 25 for this kind of design. Yeah, but I'm going to leave it here. It's not going to use 25 for me because of I'm not doing a design that is that serious. Then my link diameters, I'm going to use R8 and R10. I don't need all this, honestly. And I'm going to come to, yeah, I can reselect bars here. You discover that it changed when I select rebars because I have chosen different types of rebars here. So just click on select rebars and it's going to change. Then this is one of the things you have to do. It's very important to do this. So you have this is your soil profile, and this is where you are going to be using your borehole log. Okay, so if you can, as you can see, from level 0 to 1.5, what this borehole log is telling you is that you have very soft or soft, dark, brown, gray, silty organic peat. Whatever you have from this is what you are going to input in the data in the Prota details. So from 0 to 1.5, you have organic peat. From 1.5 to 2.5 meters down the earth, you have loose to medium dense dark brown silty sand with fine to coarse gravel. From 2.5 meters down to 5.25 meters, you have soft to firm gray silty clay. Then from 5.25 to about 15 meters, you have medium dense to dense, very coarse silty sand with fine to coarse gravel. And that is where the borehole test ended at 15 meters. So you're going to put all of this, you're going to input it in your borehole log, in Prota details. You're going to put it here. So basically, you can see this 1.5, this is from 1.5 to 3 meters, whatever you have, you're going to put it here. From 1.5, from 3 meters to 4.5, you are going to put it, whatever you think you have, you're going to put it here. Let me take that again. So from 0 to 1.5 meters, whatever thing you have, whatever soil type you have, you're going to put it here. Let's say you're going to click on it. Let's say we have sand. Click sand. Can you see that's changed? Whatever thing you have from 1.5 meters to 3 meters, put it here. Let's say we have clay. Put clay. From 3 meters to 4.5, let's say we have rock. Put rock. From 4.5 to 6 meters, let's say we have everything the way it is now to save our time. Remember that the borehole log it ended at 1.5 meters. So you just come below here, then you're just going to delete this row. You can see, delete another row and delete row. Then you can see that you have 15 meters here, and that's where your borehole test ended for the soil report we are considering. Okay, so basically, you're just going to edit this data according to what you have in your soil test. And after doing that, come to design parameters, leave it as it is. This is what your SPT looks like. Then remember to calculate, at this point, remember to calculate your working load. Calculate your working load. So your working load is 507 kilonewton. Okay, so you can come to your report, add quantity table, generate your reports. Then you can generate your report at this stage because your pile design, this is your design report. This is your pile design report here. As you can see, you can choose to convert it to Microsoft Office document or PDF, whatever thing you choose to convert it to. Then you can now click on OK. Then click anywhere on the background and you are going to have your pile designed already. Okay. And this is your pile design. So as you can see, it has used 10 T16 at 150 spacing. So the spacing is 150. You count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's your pile. This is your pile design. So you can generate the report. This is the quantity table. And you can see that our pile depth is the depth we consider is 8 meters, and that is from this point where our pie started to this point, and that's 8 meters. Okay, so you can practice it, then do pile designs for your clients and anyone that you want to do pile design for. I hope this video is very educative and it impacts you, and majorly it helps you to make more money out there with the required knowledge you need. Okay, so thank you once again for watching this YouTube channel. Thank you for subscribing to this YouTube channel. If you have not subscribed before, go and subscribe now. Do not forget to like, and do not forget to share this video. Thank you so much for once again. Remember to put your comments and questions below in the description box, and sorry, in the comment box, and we will respond to them. We're going to respond to all your questions. You can be sure that we are going to respond to all questions. All questions are important, and all questions are basically very important to us, and we're going to respond to them. Thank you once again, and have a good day.